Welcome to the Endless Platformer, a pretty simple game. Just stay alive. You've got water, grass, sand, and a variety of other materials, and you gotta figure out which ones are safe to stand on. Let me warn you, sand, probably not that safe, nor is water. As you can see, they'll fall out from underneath you. It's pretty exciting, it's a lot of fun. You can restart the game. You've got two boom boxes to choose from. One plays more mellow tones, and the other plays more poppy tones. You'll also notice we have 5 game modes, from peaceful to hardcore. Normal's where I recommend you start, and hardcore is for those who are dedicated to the jump. Let's go restart this and give it a go. 3 in a row gravel. Look at those things fall, yikes. And as you can see, this is just getting shorter and shorter. Oh no! It gets smaller and smaller very, very quickly. 30 seconds in, and it is very difficult. I highly recommend you come check this out. Welcome behind the scenes to the Endless Platformer. First thing you're gonna notice is we've got kind of our you fell out of the game world, and we end the game here. We then play a sound effect and respawn the player and cause everything to pause except for the object motion. These are our bricks. You'll notice that the colors are changing dynamically. So the brick has, every single one has a trigger on it, but the triggers are only activated when we know it's a sand or gravel. We enable the trigger, and what the trigger does is it says, hey, if I've been entered by a player, enable gravity, and then it falls out of the world. And so all objects here, except for water, have this ability. The water objects actually are just non-solid, so you just fall through them, and they actually come at the same route every single time. And that's so that we don't have a bunch of water stack up. Falling gravel is already hard enough, but having occasional water kind of is fun and throws a mix in. So there's a total of 12 blocks here. We also start with a nice black platform, which will slide out of the way and then be made invisible. And then the pieces go through perfectly. So it's the exact length for 12 pieces, and then they disappear and come back to the front. Please note that I did actually, when they get to the end, instead of teleporting it straight back, I actually teleport it down and then up to here. Because if it was teleporting straight through, it was causing a little bit of flickering, and I just didn't like the way that looked. So that was that. Another thing to note is if a player stands on top of this button, when this button gets teleported, it teleports the player with it. The same thing's true with these objects. So if you're standing on one, if it wasn't for this wall being here, it would teleport you to the beginning of it. And so that's what these invisible walls do, is they hold the player back. I put this here so that players can see exactly what types there are, and then they can make inferences about what each different means. And obviously I've kind of given some key with the visual there. We've got quite a bit of music. I've actually just imported this from my jukebox world, and they also turn off our main audio source when they are enabled and then when they're disabled. So it's very similar to the original script that we wrote, just a slight variation there. Our clouds are also a very simple script. They just slowly move. I have added a little bit of random to make it so that they move at a random speed, and so that way they come apart, so they start together and then they slowly separate, kind of like real clouds do. Our set speed script is running on the difficulty podium, and that sends a number variable to our control object, letting it know how fast we want it to be. And so that varies from 120 seconds between difficulties upping and 5 seconds on hardcore. So quite a variance there, but then you can send that through and set the variable inside of each podium. So you could have more than just those podiums. Our play sound script is really quite simple. It's just connecting to 5 different triggers. And then when the trigger is entered, we play the local trigger event, and then when trigger enters with player, we move to the position to the right hand of the player and then play sound on self, and that allows us to work on all of our buttons. All of our buttons are using this whether or not they have 2 triggers to connect to or not. So if we open up the most complicated audio, you'll see that the audio itself is running the script and that they're all tied in. You'll note there's 2 types of objects. There's the water object and the regular object. The water object is kind of a simpler version because it just does the move down command when move down is received. So control sends move down to all objects that are spawned in, and then it moves by -50 on self when that's received. And our regular object script is just a slight variance of this. It adds a bunch of if statements, which are very simple, and it's just saying, what am I? Because we send from the control object, I am, and I am is a number between 0 and 4, so that's 5 different options, representing the 5 different possibilities, excluding water. And then it changes the color, and I've used these as just type the color value in, and I got that color value from the properties panel on the attributes tab for each of the main objects. Because this is running on an object, so this allows me to do it from the script rather than from the object. So it actually saves time even though it doesn't look like it, but it is the easier way to do it. And then you'll notice if I am greater than 1, then we disable the trigger. And if I am less than 2, so if I'm 0 or 1, meaning I'm gravel or sand, we enable that trigger. And then in our control script, there's a lot going on here. In general, what we're doing is we're just spawning this in sequence. And so at the beginning, we set the start position, start rotation, and initial scale to be that of our number 6 object. Our 6th object happens to be that water source that starts at the very beginning, and that allows us to save that position and then utilize that for spawning in all of our other objects. We then set object in motion to be 6, so we know that the object 6 is the first object to start with. We also set current object to start at 6. We set the timer position to be the position of the timer podium, so we're saving that position. And then we move to vector of 0, -5, 0 on that timer podium. For reference, this is this invisible podium right here that does the restarting. And so when we want to restart, we only want that available after your first play. Then we hide that timer podium. We connect to the start trigger. So that's the trigger on the initial start down here. So we connect to that event. And we also connect to the trigger on the timer, the restart timer. And we connect to the player respawn trigger, which is the trigger below us right here. So you'll notice there's 2 different triggers. This trigger catches the player if they've fallen out of the game, and then we know that they've lost and they get respawned. This secondary trigger is kind of a backup in case there's any other issues. We have had a couple issues with players being accidentally teleported down to the bottom of the world, and this will respawn them without stopping the game so they can just jump back in. When that trigger is entered with the player, we move to position of 0, -5, 0 on our start podium, and then we hide that podium. We then send event hide platform to self with the same move speed and time multiplier that we're using. And so that's our black platform here. And you'll notice immediately afterwards, we start moving that platform to the side with the same move distance times 2. And this is just because I was playing with it, trying to get it finicky and right. And I found that multiplying it by 2 was what I liked. So it's not really important, it's just more about kind of playing with the numbers. And then we've also got move speed times 2, and you can't see the rest of it because it's just been clipped. So what I recommend is when you have a line that gets this long is start on one end and then work your way to the other end, or if you need to, grab an if statement to pull things out. But at the very end, it just says that it is tied into our platform object. We then send event loop to self with a 0.4 second delay. This 0.4 seconds gives this platform enough time to move out of the way, so there's a slight gap between the first water block and the platform. We then send event timer to self, which counts our time. We send event difficulty up after 30 seconds, so it takes 30 seconds before we increase the difficulty. And then we move to timer position on timer podium. And so this allows us to move our podium back. So the moment you start the game, that podium is activated so you can restart it. We then show the timer podium, and then when event hide platform is received, as you might have guessed, we hide the platform. When loop is received, this is our main loop, we rotate to the start rotation of object in motion. Whatever current object we're utilizing, we rotate it. This is most important for the sand and the gravel because as they fall, they kind of come out of rotation. We then move to the start position is X, Y, and Z because we're actually going to adjust our Z, which is our side to side, by a current position modifier. And that we'll come to in just a second, but basically it allows it in later levels to move side to side, so that way you can have it randomly placed across the map. And we do that on the object in motion. We then scale to the initial scale minus our current width. So this, as we get through, you'll see that we adjust the current width, but it starts as 0. So at the beginning, it starts with its initial scale, and then we slowly cut it down to size. Then we apply that to object in motion. You'll note that all of our objects are the same width. And then we move to start position plus a vector of how far are we moving, and 0 plus that current position. So we need to know how far off are we. And so our current position allows us to move to the side, however, so that way it moves parallel rather than slightly sliding ajar if it wasn't the current position. And then we do that over move speed times time on our object in motion. And then we send event loop to self after move speed divided by distance. So this math gives us the exact amount of time that it takes for it to go that speed. If you use this, it's perfectly lined up. but I had so many issues with them being right next to each other, I found that the gap of 0.4 seconds between each object was perfect. It gave enough space that you weren't always falling through, and it looked fine, it looked fun, and so I liked it. So I went with 0.4. I did initially start with like 0.1 and 0.2, but I ended on 0.4 being my favorite. Then we send event move down to object in motion. You'll remember move down at the very end of the object. So we move it times move speed times 1.35. As you can see, I just kind of adjusted this number until I got it exactly as it made it to the end. It then moves down, which prevents our object from flickering as it teleports back. And then we send event I am to object in motion. Now this one happens instantly during this whole time. This isn't after any period of time. And that's with random integer 0 to 5. And this basically says you're going to be this color, you're going to have these attributes, and then the object, you'll remember, had taken care of that inside of it with a bunch of if statements. We then set our next current object to current object plus 1. So this basically cycles through our objects. We then set current position to be a random integer between 0 and current width. And our current width is a number that we'll set later, which loops with our difficulty getting higher. And we do that with a minus, so it's between 0 minus the width, so we get a negative, as well as a positive. And we add 1 to our positive rather than starting from 0 because it's exclusive of the upper number. It's inclusive of the bottom number, so if you have, say, 0 and 1, it will only be 0 because it doesn't include 1. But if you have 0 and 2, it'll be 0 or 1. And then we divide that by 2 to get the exact position because we don't need it to go outside. We could have divided current width by 2, but by dividing it over here, we're going to have to only use 1 division rather than 2. And that keeps it within the parameters of this 5-block space because 0 is in the center, and if we just shifted it, it would be off-centered. If current object equals 1, we set object in motion to 1. So remember up here, we set current object to cycle up to the next one, up to the next one, up to the next one. You theoretically could have this be a random number, so it's constantly selecting a random. But because of the way I've set this up, there's only space for 12 objects, so I need it to happen in cycle. I need it to be always selecting the last one. So this works really well because I'm changing that object. So I'm still getting random, but I'm using the same objects in cycle, so we're always having exactly how many we need. And so it goes through 1, 2, all the way through 12 objects. And so all that does is set object in motion to be 11 or whatever object it is, and then at the very end it sets it back to 0, so that way it restarts it from the beginning. Then when event timer is received, we send event display text to self. We then set time to be time plus 1, and then we send event timer to self with 1 second. So this way it's cycling up by 1 second. So we get an accurate timer, and then we're updating our display. And you'll remember this display text from our countdown tutorial. And if you haven't already seen that and you want to do a timer, I highly recommend that video. I'll make sure there's a link to it. And that sets seconds. It also sets minutes. And then if seconds is less than 10, we display it with a 0, so that way it looks correct. And if seconds is greater than 9, so it's 10 or greater, we then remove the 0, so that looks accurate. And so we have two different displays displaying the difficulty plus minutes as a string plus the string, which gives us our colon, plus seconds as a string, and we do that on our text object. Then when timer reset is received, so we get this object from our podium, we then cancel sending event timer to self, so we stop updating our timer. We set time to be 0. We set current width to be 0, so we reset all of our variables. We send event display text to self, so we update the display to show 0. We then send event timer to self with a 1.5 second delay, meaning it won't start counting upward for 1.5 seconds. This gives it time to show this 0 on the display. We then send event difficulty up to self after difficulty speed. Difficulty speed is variable based on whether you click hardcore, hard, etc. And then we have when event timer pause is received. So that's when the player falls through the world. We then cancel sending event timer to self. We cancel sending difficulty up to self. And when event difficulty up is received, which you'll remember starts at the very beginning with a 30-second delay, and then if the number 4 is greater than our current width, we set current width to be current width plus 1. So this increases the width of our subtraction. And so we start with 5 block width, we subtract 1, and then we subtract 2, and so forth. and we do that up to 4 times, and then we get down to 1 block, and then for our really hardcore setting, we go to 4, and we set it to be 4.5, leaving only that half sliver. So it's pretty cool. And then we send event difficulty up with the difficulty speed, and so that continues to repeat. We then set speed, and so this is when we receive set speed from those 5 podiums with the difficulty on it. And we'll receive difficulty speed as a speed number, which is either 120, 60, 30, 15, or 5. And if speed is 120, we write the difficulty as a string peaceful. So this allows us to add that to our text object, so that way it displays correctly on our counter. And we do that for all the different difficulties. And then we send event display text to self after 0.2 seconds, allowing us to update our display as soon as you press the button. And that's it. It's a lot, don't get me wrong. If you'd like a copy of this, I'd be happy to share it with you so you can kind of break it apart and learn. But if you have any questions, don't hesitate to ask, and I look forward to seeing the next one. Bye!